morning, Nathan. Well, I stayed super late last night. It was almost 9 o'clock before I left, but it was just grading papers. So I didn't have time to make out your notes video. So I got here super early this morning to do it. All right. So you learned yesterday that there are 5 ways that we can prove triangles are congruent. Oops, turn the pen on. So there's side, side, side congruency. There's side, angle, side congruency. There's angle, side, angle. There's angle, angle, side. And hypotenuse, leg. But remember, this one, right triangles only. Okay. So basically, we're just going to walk through how you prove triangles congruent, and once you know they're congruent, how do we name them, and how do we write down the congruency statement correctly? So this one, here's a side that matches this side. So like I can say, oh, here's side 1. Okay, here's a side that matches this side. There's side 2 that's congruent. This is a third side congruent to a third side. So these 2 triangles are obviously congruent because the side, side, side congruency postulate. Okay, now when we name them, we have to look at where everything sits. So we got to put the triangle symbol. So A is the angle that's included between side 1 and side 2. That's where angle E is. So it's got to come first because we have to have the corresponding parts have to be in the same position in the name of the triangle. So B is between sides 1 and 3. 1 and 3, that's where F sits. And then that leaves D for last. Okay? All right, number 2. There's going to be sides that are congruent to themselves. So like this side is congruent to itself, and it's in both triangles. So you've got a side matching another side. Here's a side that matches another side. Here's a side that matches the other side. So it's going to be side, side, side. Okay. Now, when we look at this, which again, I think we should put this, we're doing triangle ABC. Okay, so this one you really have a choice in how you want to say it, because like the only angle that has to be in the exact same spot is this angle being congruent to this angle, because it's between the sides that are marked with 1 tick mark. So I know the one that has to be in the middle has to be D. But you really got some leeway. If you called it triangle ADC, no one would care. If you called it triangle CDA, no one would care. Personally, I would probably, just because, and nobody knows for sure, but it looks like a parallelogram. I'd say those are probably the congruent angles. I'd probably put angle A in, let's see, angle C in triangle ABC going with angle A. I'd probably put the A at the end. But it really wouldn't matter. The only one that matters is the D had to be where it was. Okay. All right, so we have a side. So let's say here's side 1, matches side 1. Side 2 is congruent to side 2. And the angle in between those sides is congruent. So it's like you're just walking down. Side, angle, side. Side 1, the angle, side 2. So these are congruent by side, angle, side. And when we name it, all right, so angle A, we've definitely got to name angle E first. Okay, angle B is at the end of side 1. So that's got to be angle D. And then that leaves F for last. All right, let's see what we got here. So you mark up anything that you know. So these 2 triangles, like if you look at the 2 small triangles, they share that side in common. So what's happening over here on the triangle on the left is it goes side, side, angle. Over here it goes side, angle, side. Those are not congruent. I mean, they could be. Don't get me wrong. There's a chance they're still congruent. But with what we know right now, they don't have to be. So we cannot say that those are congruent triangles. Okay. All right. So here's what I would suggest. Stop the video and for 5 through 10, see if you do the whole thing, and then come check my work and I'll talk about. So I'm going to keep talking because you're supposed to stop the video already. Hang on. Since you're stopping, I'm just getting a sip of coffee. All right, let's see what's next. Well, first, these 2 triangles are right triangles. So that puts hypotenuse leg on the table. However, it's not going to be hypotenuse leg because I do know there's a hypotenuse congruent in both of them, but I don't know anything about the legs. So that's going to take that off. But see how you've got the right angle? Like, say this is, why's the pen not working? Come on. Okay, so let's say that there's angle 1 is the right angle. And then you move along and you hit angle 2 that's congruent, and then you hit a side that's congruent. So these two triangles are congruent by angle, angle, side. And when we, so MAD, that's one on the left. M is, that doesn't even look like a triangle. Okay, so M's going to come first. A's the right angle, so B will come second, C will come last. Okay. All right. These, you've got a pair of vertical angles. So you mark it up, and then you've got side, angle, side. So these are congruent triangles by the side, angle, side congruency postulate. And then here's how we'll name them. So angle A is at the end of that side 1. So that's where angle C sits. So we'll put it first. B is the other one that's not marked up, and then E was that vertical angle. Okay. Right here, they share this side in common, so mark it. And then you got side, angle, side. Side, angle, side. So triangle ACB is congruent to triangle ADB. Okay, all right, this one, we've got this side they share in common. This is definitely a side, side, side congruency. So we know that triangle MNP, okay, so M is down here included between sides 2 and 3. So that's also angle M in the other one. N is the one between sides 1 and 2. So that's where the Q sits. P comes last. Okay, there's a lot going on right here. Let's see. So there's different sets of triangles. Like if you were looking at, oh wait, hang on. We don't have to wonder what to look at. Angle, triangle JKL. Okay, so we're looking at this one. All right. Sometimes I think it helps to redraw them when they overlap. Like when they're up against each other, that's great. There's no reason to redraw those. But when they overlap like this, I think it's super handy to actually redraw them out separate from one another. But, okay, so I know, oh, go back. I'm struggling this morning. I've struggled a lot of mornings, have you noticed? So they told us this. They told us this angle is congruent to this angle. And they share that side right there in common. So these two triangles are congruent by side, angle, side. And, okay, so triangle J is at the end of side 1, not marked angle, so that's M. K is next. That's the one that they told us about, and that leaves K to come last. All right, so this one, all right, we have the angle. They share a side. But see, this goes ASS. And that's always a joke in geometry, is like, don't make an ass of yourself. That's not one of the congruency postulates. That does not prove anything. So these two triangles, could they be congruent? Sure. Do I know they're congruent? No. All right. Let's see what we got in here. So question number 11. Let's mark things up. I know that this angle has to be congruent to this angle because they're both vertical angles. Okay, that's 68 degrees. This is 68 degrees. All right, so look at this. Those two angles are congruent to 68. So two angles in a triangle being congruent imply that all three are. So I know this has to be 75 degrees. It says find the measure angle DC. Oh, just found that. 75 degrees. What additional information is needed to conclude that triangle NDC is congruent to triangle NSR? Okay. What other information? Because right here, you could go angle, angle, side. So 68, 75, side 1. 68, 75, side 1. We're good. Maybe, I even put a star next to this on my other notes. You really don't need any addition. Like, let's say none, because they're congruent by angle, angle, side. Or angle, side, angle. Either one of them would have worked. Because we showed that all three angles had to be congruent. So, I'm not real sure what that was getting at. I don't remember. Because I don't need any additional information once I did this. Like, I mean, I guess technically, maybe what we were thinking back then was like we needed to know that to get the, well, but still, I don't know. There is no more information. We're good. We can say they're congruent. All right, so this one they're saying the triangles are congruent. So this side definitely they have in common. And this is another one, like, can you tell this is not my type? Like, when I type it up, it's always in that Cambria math font. This is something that we cut and pasted from something else. So sometimes I'm not crazy about these questions because I didn't come up with them myself. Hang on, I just got an email. Let's see who it is. Oh, it's Google Calendar telling me that I have no events scheduled today, which is a lie because I don't put anything on my Google Calendar. Okay, so this is one of these, you can, should you assume anything? And I already said ask once a day, so I'll tell you the other saying about assuming. So this is another joke we like to make in geometry. You don't assume anything in geometry because that will make that out of you and me. And I'm going to erase that because I probably shouldn't put it. Okay, but again, this is an assumption. But I think it's probably an accurate assumption. Because that angle looks the same size as this angle. This angle looks the same size as that angle. So I would say that triangle PXY. So I would put the T first, X second, and Y last. However, again, I can't tell you that with 100% certainty because I am assuming that this thing is drawn to scale. And you should never assume it's drawn to scale. So this is kind of iffy to having a set of notes. All right. So if that is the case, though, so for the rest of this, we are going to assume this is correct, which is just a weird way of doing this. All right. What has to be congruent to angle T? All right. Well, angle T sits in the same spot angle P did, and that's because corresponding parts of congruent triangles are congruent. Now, when you write those letters, corresponding parts of congruent triangles are congruent. Don't just say CPCTC. Like Miss Bazemore, she was my math teacher for 3 years in high school. Whenever we would do this, she was hilarious. She would dance around the room and go CPCTC, hey, CPCTC, hey, and she'd kick up her legs, and none of us will ever forget it. But I also think that there was a lot of people sitting in that room that has no idea what the CPCTC meant. So make sure that when you say it, like, say the words, don't just write the letters, okay? All right, next, if we say we're looking at side XP, all right, so we're going XP, then we have to say XT. You cannot call it side TX, okay? The corresponding parts have to sit in the matching, in the same spots, and that's because corresponding parts of congruent triangles are congruent. All right, if we know that YX, okay, so that line segment bisects angle PYT, then that means it cuts that angle in half. Because we know this because, what should we put? Oh, we're saying why do we know it bisects it? Never mind. I'm totally misunderstanding the directions. We know this because angle 1 is congruent to angle 2 because corresponding parts of congruent triangles are congruent. Okay. All right. The next 4 do the same thing. Stop the video, try these 4, come back and check. I'm going to keep going, checking your work. All right, if this is a straight line, then those 2 both have to be right angles. So we kind of have our choice here. And also, the big triangle is an isosceles triangle. And in an isosceles triangle, the sides, oops, I guess I do 3 tick marks. The sides opposite each other have to be congruent. So we kind of got our choice here. We could, it is congruent, those 2 triangles are congruent because of the hypotenuse leg. However, we had to do some work to get to there. So that is never the one that you would say is the reason. Like, if you can, anything that I guess, appears quickest, that's the one you should go with. Because once you figure out the two triangles are congruent, then all the corresponding parts are congruent. So all 5 reasons will end up being true. You see what I'm saying? Like, so you don't want to like, oh, I'll mark everything because I know they're congruent and da 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 da. So you probably don't want to like, you don't want to do a deep dive when there's something on the surface. So this is what I'd look at though. I'd probably go side, oops, dang it. I'd probably go side, angle, side, because you know those are both right angles. That might be the first one I get. What if we didn't put that right angle, side angle? That wouldn't have done it. Let's see. Oh, but we could have also said angle, side angle, angle, side angle. Those are the two that are just like glaring at you, going, "Hey, this is the reason these two triangles are congruent." And up in the directions, it did not say that you had to write the congruency statement, so I'm not gonna. You're gonna have plenty of practice with that. All right, so let's mark this up. So we know that angle M is congruent to angle O. We know that X, Y, and MO bisect each other, which means they run through the midpoints, and the midpoint divides these up into congruent segments. And then we also, well, do we have enough right now? Right now it's angle, side, side. That's not a reason. But we also know we got a set of vertical angles right there. So that, we got all sorts of reasons. Angle, side, angle. Angle 1, side 2, angle 2, angle 1, side 2. Let's say angle, side, angle right there. Angle, oops. Side angle. That's probably where I'd go first. Angle, angle, side. Not angle. Do I have angle on the side? I could look at like angle 1. Let me change colors. Angle 1, angle 2, side 1. Angle 1, angle 2. You could do angle, angle, side. Like there's so many different ways you could do this, but that's probably the two you'd probably want to go with most. Now, when we work with this, look what we've got. Okay, there's a pair of alternate interiors. They're congruent. I know those are parallel. Like we can just keep going, which makes these congruent, but also those are congruent because corresponding parts of congruent triangles are congruent. Okay. We know this has to be a right angle. We know they share that side in common. That is all we know, right? So angle 1, the right, so let's do this. Angle 1, the right angle, and then side 2. Angle 1, side 2, then the right angle. That's not the same order. Those are not congruent triangles. They do not have to be. Okay? This one, triangle ABD. Okay, again, these are overlapping, so I think it's worth drawing these out. And CDB are right, angle ABD and angle CDB are right angles. We know that. They share this side right here in common. But that's all we know. We've got a right angle and a leg. We've got an angle on the side. That is not an, wait, or do we? Oh, wait. Oh, I'm not looking at all the givens. AD is congruent to BC. Ah, there it is. So here's a hypotenuse, and there's a leg. It probably helped to look at all the, the things they tell you are true about it. So these are congruent because of hypotenuse leg. Wait a second. Hang on. 3, 1, 2. 1, 2. No, that's good. I'm look at it. This one again. No, those have to be congruent. Nothing's out of order, is it? 1, 2, 3. 1, 2, 3. Got side ones between 2 and 3. This is the right place. Okay, no, I'm good. The reason I'm looking is I always look back at my old notes when I'm doing this to make sure I haven't forgotten to talk. Oh, I skipped a page. Make sure I haven't forgotten to talk about something. And I didn't have this written down for that one. So it's like, wait, are those triangles not congruent? I think we're good. They have to be congruent, right? Yeah, okay. That's the first part of this. I think I'm going to stop the video right now just because I can go ahead and get it uploaded because the rest of this is all proofs. So this seems like a good place to make this 2 videos.